Hello, my name is Kelsey from SimQ. Today, I will present our SimQ VIT software for virtual implant testing. Let me show you how SimQ VIT assists in verification, strength assessment, and safety of patient-specific implants. To start, we click the desktop SimQ icon to open the software. We can now set up highly complex biomechanical simulations for each patient within minutes. So when starting a new project from the dashboard, the user can see the different workflows for different anatomical regions and implant types. More workflows are soon to follow and can be set up based on customer needs. Let's open our Maxillary Subperiosteal Implant workflow. In order to set up a simulation, we simply import the bone, denture with abutment, implant, and screw STL files. We then choose the materials for the implant and screws. Different materials are implemented in our library, and of course, more can be added according to customer needs. Next, let's set the landmarks. To register the patient-specific geometry to a known reference model, these are represented by planes. All the landmarks are labeled anatomically, and a step-by-step guide is pictured on the right. Once the landmarks are set, two planes will appear. The top green plane should cut through the entire skull and acts as a support. The bottom purple plane should follow the occlusal plane between the rows of teeth. Once verified, now choose a Loadcase from a predefined selection. These are also customizable according to customer needs. Here the user can change the Loadcase position by simply moving the main force arrow. Now we save the project and send it for simulation. Projects are sent to the cloud and calculated. Results can be retrieved within 15 to 45 minutes depending on structure complexity. Once we retrieve and download the simulation from the server, we see several different results for review. The first result, material limit exceeded. This is represented by a two-color scale, green and red. Here, the user can easily see the areas in green that are below the material limit and the areas in red that are above the material limit. Designers know when the material limit is exceeded, this can lead to damage of the material when under the selected load case during the project setup. Number 2, total deformation. This result is represented by the more colorful scale and shows a deformation both in location and how much in millimeters, independent of force direction. Number 3, normalized strain of the bone. This result shows the areas in which the bone is under high strain. This means that a higher force is transferred to these areas. Areas around the screw holes should particularly be observed. Number 4, shear stress of the implant. When a force acts parallel to the surface of an object, it exerts a shear stress. So when this is high, the material could be damaged due to shearing forces. Number 5, tension stress of the implant. This force should be considered because different forces pull on the material of the implant. If there are small flecks of red in the screw hole area, this is a singularity and is negligible. Contact regions should be applied in this context. Number 6, von Mises stress of the implant. This is a mix of tension, shear, compression, bending, and torsion stresses into one, considering a mix of all stresses in the implant material. Number 7, screw force direction, screw to implant. When a patient bites down, the screws must hold the patient implant in place. In order to hold the implant in place, the screw must exert force on the implant. The arrows point in the direction of that force through the implant and into the bone. Number 8, screw force direction, screw to implant. These values are from 0 to a maximum. There's no material limit here, but the screws are colored according to the forces. The designer can observe the colors of the screws and the force direction with this result. Now that all the results are reviewed and the implant design is finalized, you can save an implant-specific report for technical documentation and QM systems. Our basic simulation report is available to all customers with any SimQ VIT subscription. We also offer FDA compliant reporting, which is always up to date and based on the latest published FDA guidelines. SimQ VIT easily creates this report with a few clicks, saving time and valuable resources. In summary, the workflows implemented in SimQ VIT software provide a robust, reliable, and fast solution for the assessment of mechanical stability of patient-specific implants. The results of patient-specific simulations can be utilized by medical device manufacturers and medical professionals alike to improve the implant designs and avoid implant failure. Workflows for other anatomical regions can also be implemented together with customers. Stay ahead of the competition and benefit from our new innovative software, SimQ VIT. We look forward to hearing from you.
SimQ, we personalize patient care with simulation.